Hello and welcome. If the D570 OA exam has been on your mind and you're wondering how to approach it, then you're in the right place. Our website has D570 OA questions and answers, and it won't cost you a thing. OA exams are tough, so everything from guides to practice questions is free. With over 100 plus success stories, we have proven our videos will help you pass your exam on the first attempt. In this video, we will cover questions from early psychologists, developmental theories, cognitive neurobiology, visual imagery, language and memory. So, let's get started.
Question 1. A 19th century researcher measured how long it took participants to press a button after seeing a single light, and then how long it took them to choose between pressing different buttons for different colored lights. He used the time difference between these two tasks to estimate how long a single mental decision took. Which researcher pioneered this approach? Your options are A. Wundt, B. Donders, C. Ebbinghaus, D. Watson. Which one is it? Pause the video if you need more time. The correct answer is B. Donders. B is correct because Donders performed the earliest experiments measuring reaction time as a way to estimate the duration of mental processes. Subtracting simple reaction times from choice reaction times to isolate the time required for a decision. I was wrong because Wundt founded the first psychology laboratory in 1879 and emphasized analytic introspection of conscious experience, but he did not design the subtraction method for measuring decision time. C is wrong because Ebbinghaus is known for his work on memory and forgetting using nonsense syllables, not for measuring the time required for a single mental decision. D is wrong because Watson founded behaviorism and rejected the study of internal mental processes altogether. So the subtraction method for inferring mental events would have run counter to his approach. Before 1868, the duration of a mental event was considered either instantaneous or simply unmeasurable. Donders changed that forever by showing that the time a thought takes can be captured with careful experiment design. Donders compared a basic press when you see a light task against a choose which button task. Subtracting the simpler time from the complex time isolates the single mental step added, the act of choosing. The logic is elegant. Hold everything constant between the two tasks except one inserted mental step. If the only addition is a decision, then the time difference equals the duration of that decision, the first quantitative ruler for a cognitive operation. The method rests on pure insertion, that exactly one new step is added, and additivity, that each stage's duration simply sums into the total. Modern researchers know these assumptions often fail, yet this framework seeded every reaction time study that followed. Donders didn't describe consciousness like Wundt, and he didn't reject it like Watson. He measured it, establishing that mental operations are discrete, stageable, and quantifiable. That methodological insight is the foundation of cognitive psychology as an empirical science. Question 2. A graduate student in 1890 travels to Leipzig, Germany, and joins a laboratory where trained observers carefully report the basic sensations and feelings they experience while listening to a metronome. The lab director treats these introspective reports as the raw data of mental life. Which approach is the student being trained in? Your options are A. Structuralism using analytic introspection, B. Behaviorism using observable conditioning, So, functionalism using stream of consciousness narratives. D. Cognitivism using reaction time subtraction. Take a second, which answer would you pick? The correct answer is A. Structuralism using analytic introspection. A is correct because Wundt's Leipzig laboratory used analytic introspection to break conscious experience into elemental sensations and feelings, an approach later labeled structuralism by his student Titchener. B is wrong because behaviorism rejected introspective methods and focused on observable stimulus-response connections rather than internal experience reports. C is wrong because functionalism, associated with William James, asked what mental processes were for rather than cataloging their elements through structured introspection. D is wrong because reaction time subtraction is associated with Donders, and the broader cognitive movement using such methods did not coalesce until decades later in the 1950s and 60s. Structuralism was psychology's first experimental school, built on a simple but ambitious idea: break conscious experience down into its smallest irreducible parts, the way a chemist breaks matter into elements. In 1817, Wilhelm Wundt opened his Leipzig laboratory and introduced analytic introspection. Wahid, not casual self-reflection, but years of rigorous training to report the immediate, raw qualities of experience rather than its meaning or interpretation. It helps to place structuralism alongside its rivals. William James's functionalism asked what mental processes are for, not what they're made of. Watson's behaviorism rejected introspection altogether. Structuralism's signature is the trained observer cataloging elemental sensations in a late 19th century German laboratory. Wundt's dream was a periodic table of consciousness, a finite set of basic sensations and feelings whose combinations could account for every richer mental experience, just as a handful of elements combine into all known matter. When an exam stem mentions the first psychology laboratory, trained observers reporting elemental sensations, or late 19th century Germany, that's structuralism and Wundt, not James, not Watson, not later cognitive psychology. Question 3. A cognitive psychology instructor wants to demonstrate that memory for newly learned material drops sharply within hours of learning and then levels off as time passes. He plots retention against elapsed time and shows the steep early decline followed by a gentle slope. Which classic finding is he illustrating? Your options are A. Sperling's iconic memory decay, B. The serial position curve, C. Ebbinghaus's forgetting curve, D. The reminiscence bump. Before I reveal it, which one do you think is right? The correct answer is C. Ebbinghaus's forgetting curve. C is correct because Ebbinghaus tested his own retention of nonsense syllables across delays and produced the curve showing rapid early forgetting followed by a slower rate of loss, the classic forgetting curve. A is wrong because Sperling's iconic memory work showed the brief persistence of visual sensory memory across milliseconds, not the multi-hour curve of forgetting for studied material. B is wrong because the serial position curve plots recall accuracy against item position in a list, producing primacy and recency effects rather than a time-based forgetting function. D is wrong because the reminiscence bump describes the disproportionate recall of memories from adolescence and early adulthood, not the rate at which freshly learned items are forgotten. The forgetting curve describes how memory fades over time, steeply at first, then more gradually. Ebbinghaus published this finding in 1885, and it has held up through over a century of replication. Ebbinghaus studied his own memory using meaningless nonsense syllables, which stripped away prior associations. His key measure was saving, the time saved when relearning a list compared to the original learning. The curve has a characteristic shape, a sharp plunge in the first few hours, when memory traces are most vulnerable to disruption, followed by a long, slow decline. Most forgetting happens before the first day is over. The forgetting curve is often confused with two other concepts: The serial position curve plots recall by list position, showing primacy and recency effects. Iconic memory decay is the loss of a fleeting visual image within about 1 second, far faster than the hours today's time scale of the forgetting curve. When an exam stem mentions nonsense syllables, the savings method, or rapid early forgetting followed by a slow tail, Ebbinghaus is the answer. No other figure produced the first quantitative laws of memory. Question 4. A psychology department chair in 1913 argues that the field should restrict itself to observable, measurable behavior and abandon the study of consciousness, mental images, and introspection altogether. He famously demonstrated this stance by conditioning a fear response in a young child known as Little Albert. Which figure is being described? Your options are A. William James, B. Wilhelm Wundt, C. B. F. Skinner, D. John B. Watson. What's your answer? Commit to one before I continue. The correct answer is D. John B. Watson. D is correct because Watson published his Behaviorist Manifesto in 1913 and conducted the Little Albert study, arguing that psychology should be a strictly observable science and rejecting introspection. A is wrong because James was a functionalist who valued the study of consciousness and adaptive mental processes rather than rejecting them. B is wrong because Wundt founded the first experimental laboratory and used introspection, the very method behaviorists rejected. C is wrong because Skinner came after Watson and extended behaviorism with operant conditioning, but the founding manifesto and the Little Albert demonstration belong to Watson. Behaviorism redefined psychology by insisting that only observable behavior was not consciousness or inner experience. Goals could be studied scientifically. The movement was launched by John Watson in 1913 with a landmark manifesto that changed the discipline for decades. Watson argued that the disagreements among introspectionists, different labs producing different catalogues of conscious elements, proved the method was broken. His solution was radical: strip psychology down to only what could be publicly observed and replicated. The Little Albert study in 1920 made the framework concrete. By pairing a white rat with a sudden loud noise, Watson and Rayner produced a conditioned fear response in an infant, demonstrating that emotional reactions could be learned without invoking any unobservable feelings. The most common exam error is conflating Watson with Skinner. Watson founded behaviorism and demonstrated conditioned emotional responses. Skinner came later and extended the framework through operant conditioning, shaping voluntary behavior with reinforcement and punishment. When you see 1913, Manifesto, Rejection of Introspection, or Little Albert, the answer is Watson. Skinner's operant work is broader and better known, but the founding moment belongs to Watson. Question 5. A textbook describes a researcher who published a foundational 1967 volume that named and defined a new field of study, organized work on perception, attention, memory, and thought, and effectively marked the transition away from strict behaviorism. Which figure does this describe? Your options are A. Donald Broadbent, B. Ulrich Neser, Sir Edward Tolman, D. Alan Newell. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B. Ulrich Neser. B is correct because Neser's 1967 book Cognitive Psychology gave the field its name and consolidated work across perception, attention, memory, and thinking, earning him the label Father of Cognitive Psychology. A is wrong because Broadbent contributed the early selection filter model of attention and was an important figure in the cognitive shift, but he did not write the volume that named and defined the field. C is wrong because Tolman demonstrated cognitive maps in rats, challenging strict behaviorism, but his work predates and does not include the foundational 1967 textbook. D is wrong because Newell, with Simon, helped develop computational models of problem solving such as the general problem solver, but those contributions were in artificial intelligence rather than the textbook that defined cognitive psychology. Cognitive psychology as a unified discipline didn't emerge on its own. It needed someone to pull the scattered pieces together and give them a name. That person was Ulrich Nasser. By the late 1950s, researchers had built powerful models of attention, problem solving, and memory, but these existed as separate islands. There was no shared framework, no common vocabulary, and no textbook binding them together. Nasser's 1967 book, simply titled Cognitive Psychology, drew these threads together into one discipline. It formalized the idea that the mind is an information processing system, taking in sensory input, transforming it through stages, storing it, and using it for thought and reasoning. This framework borrowed directly from computer science, treating mental events as processes operating on internal representations. Each stage could be studied empirically, modeled, and broken into substages, giving researchers a shared scientific language. Broadbent, Newell, and Atkinson and Schifrin all made foundational contributions, but none of them wrote the volume that named and defined the discipline. On exams, the founder of cognitive psychology is Nasser, full stop. Question 6. A preschool teacher notices that her 4-year-old student struggled to understand that a tall, thin glass and a short, wide glass can hold the same amount of juice. According to Piaget, which stage of cognitive development best describes these children? Your options are A. Pre-operational stage, B. Sensorimotor stage, C. Concrete operational stage, D. Formal operational stage. Which would you go with? Lock it in before the reveal. The correct answer is A. Pre-operational stage. A is correct because children in Piaget's pre-operational stage, roughly 2 to 7 years of age, have not yet mastered conservation, so they judge volume by a single perceptual feature like height, instead of recognizing that quantity remains constant across changes in shape. B is wrong because the sensoromotor stage covers infancy and the development of object permanence, not the conservation reasoning that emerges later. C is wrong because children in the concrete operational stage, beginning around age 7, can perform conservation tasks correctly because they understand that volume is preserved when shape changes. D is wrong because the formal operational stage involves abstract and hypothetical reasoning in adolescence and adulthood, well beyond the simple conservation task described. Piaget proposed that children move through 4 qualitatively distinct stages of cognitive development, each with its own internal logic, not just more knowledge, but a fundamentally different way of thinking. The sensoromotor stage ends with object permanence. The pre-operational stage spans ages 2 to 7 and sits between action-based infant thinking and logical thought. Concrete operational brings conservation, and formal operational adds abstract reasoning. The defining feature of pre-operational thought is the absence of mental operations, internalized, reversible actions. Children center on a single perceptual feature, like length or height, and cannot mentally reverse a transformation to recognize that quantity is preserved. A classic demonstration: 2 equal clay balls, one rolled into a sausage. The child insists the sausage has more clay because it looks longer. This is centration in action. The child lacks the reversibility needed to recognize that shape change preserves volume. Remember, conservation failure diagnoses the preoperational stage, not sensor, emotor, or concrete operational. And Vygotsky's zone of proximal development is an entirely different theory. No stage structure, no conservation tasks, just assisted versus independent performance. Question 7. A reading tutor works with a second grader on a passage that the child cannot quite decode alone, but can read accurately when the tutor sounds out the first word and prompts him through tricky sections. The tutor is intentionally working in the gap between independent ability and assisted ability. Which concept best describes this gap? Your options are object permanence, B. Conservation, C. Universal grammar, D. Zone of proximal development. Don't overthink it. Which one feels right? The correct answer is D. Zone of proximal development. D is correct because Vygotsky defined the zone of proximal development as the range of tasks a learner cannot complete alone, but can complete with guidance from a more capable partner, which is exactly the space the tutor is operating in. A is wrong because object permanence describes an infant's understanding that objects continue to exist when out of sight, a Piagetian concept unrelated to scaffolded reading instruction. B is wrong because conservation refers to the recognition that quantity stays constant across perceptual transformations, another Piagetian concept rather than a Vygotskian zone. C is wrong because universal grammar is Chomsky's claim about innate linguistic structures and has nothing to do with the assisted learning gap that defines this scenario. The zone of proximal development describes the space between what a learner can do alone and what they can do with help. Vygotsky introduced this idea in the 1930s as part of a broader theory that placed social interaction at the very heart of how minds develop. Think of development in 3 bands. Below the zone is everything already mastered. No growth happens there. Above the zone is everything still out of reach, even with assistance. That territory produces frustration, not learning. The zone itself is the productive middle band where guided support turns failure into success. As a learner internalizes the support, absorbing the guidance into their own thinking, the zone shifts upward. Yesterday's assisted task becomes today's independent achievement, and a harder task moves into the zone. The art of teaching is identifying where that zone sits at any given moment. On exams, the key is distinguishing Vygotsky from neighboring theories. Piaget emphasizes individual stage progression through encounters with the physical world. Chomsky proposes inborn linguistic structure. Behaviorism focuses on reinforcement. Whenever you see scaffolding, a more knowledgeable other, or assisted performance exceeding independent ability, that is Vygotsky. The zone of proximal development reminds us that the most powerful learning happens not in isolation, but in the supported space between what a learner already knows and what they are just beginning to reach. Question 8. A linguistics lecturer argues that children across very different languages and cultures acquire complex grammatical rules with limited explicit instruction and surprisingly few errors, suggesting an innate cognitive capacity specialized for language, whose theoretical position is being summarized. Your options are A. Skinner's verbal behavior account, B. Piaget's stage theory, C. Chomsky's universal grammar, D. Vygotsky's social mediation. Got a guess? Lock it in. The correct answer is C. Chomsky's universal grammar. C is correct because Chomsky proposed that humans are born with a universal grammar, an innate framework that explains how children acquire complex linguistic rules quickly and uniformly across languages despite limited explicit teaching. That is wrong because Skinner's account treated language as learned through reinforcement of verbal behavior, which Chomsky famously criticized as inadequate to explain the speed and pattern of acquisition. B is wrong because Piaget tied language development to broader cognitive stages rather than positing an innate language-specific module. D is wrong because Vygotsky emphasized the social and cultural transmission of language, a different mechanism from the innate grammar account being described. Universal grammar is the idea that humans are born with a built-in cognitive framework for language. Not any specific language, but the abstract architecture that makes learning any language possible. This theory, introduced by Noam Chomsky in the late 1950s, fundamentally changed how we think about the human mind. Chomsky attacked behaviorist explanations by pointing to three patterns reinforcement cannot explain. Children produce sentences they've never heard, apply grammar rules nobody taught them, and reach fluency on the same timetable across wildly different languages and cultures. Think of universal grammar as a shared foundation. Two toddlers, one in Tokyo, one in Bogota, begin with the same innate principles. Local language exposure simply sets the parameters. Producing Japanese grammar in one child and Spanish grammar in the other, with no explicit instruction required. When an exam stem mentions an innate, language-specific capacity that explains the speed and uniformity of acquisition, those are Chomsky's signal words. Poverty of the stimulus is the key argument. The language children hear is too incomplete and noisy to account for the rules they ultimately master. The exam trap is swapping Chomsky for another theorist. Skinner explained language through reinforcement, exactly what Chomsky refuted. Piaget tied language to general cognitive stages, and Vygotsky emphasized social interaction. Only Chomsky argues for an innate, language-specific mental structure. Question 9. A developmental researcher studying motor skills records steady, gradual gains in a child's grip strength every month from age 2 through age 6. There are no abrupt jumps and no qualitatively different stages. Which view of development do these data best support? Your options are A. Continuous development, B. Discontinuous stage development, C. The cultural life script hypothesis, D. The reminiscence bump. Which one is it? Pause the video if you need more time. The correct answer is A. Continuous development. A is correct because continuous development describes gradual, incremental change in a skill or trait, exactly the pattern of steady monthly gains the researcher observed. B is wrong because discontinuous development implies qualitatively different stages with abrupt transitions, the opposite of the smooth pattern in this scenario. C is wrong because the cultural life script hypothesis explains autobiographical memory patterns shaped by culturally expected events, not the trajectory of motor skill growth. D is wrong because the reminiscence bump is an autobiographical memory phenomenon, unrelated to whether physical development is continuous or staged. One of the oldest debates in developmental psychology asks whether psychological growth happens gradually or in distinct stages. The answer turns out to depend on which trait you're studying. Continuous development means the same underlying processes steadily accumulate strength and knowledge over time. Discontinuous development means the child operates by genuinely different rules at different ages, not just more of the same, but something structurally new. Vocabulary growth is the classic continuous example. Children add roughly 9 words a day between ages 2 and 6, producing a smooth upward curve. Object permanence is the classic discontinuous example. Sharkes said, infants suddenly begin searching for hidden objects around 8 months. A shift Piaget saw as structural reorganization, not gradual sharpening. Behaviorist and learning theory traditions explain development as steady accumulation of associations and skills. Piaget argued for qualitative reorganization at each stage. Modern accounts often describe overlapping waves of competence, with softer boundaries than strict stage theory suggests. The exam trap is treating this debate as settled. The textbook answer is that human development includes both patterns. Gradual, smooth growth signals continuous development. Qualitative before and after shifts signal discontinuous, stage-based development linked to Piaget. Question 10. A 65-year-old woman scores higher than her 30-year-old colleagues on a vocabulary and general knowledge test, but slightly lower on a novel pattern completion puzzle she has never seen before. Which contrast best explains the pattern? Your options are A. Episodic versus semantic memory, B. Crystallized versus fluid intelligence, C. Procedural versus declarative memory, D. Top-down versus bottom-up processing. Take a second. Which answer would you pick? The correct answer is B. Crystallized versus fluid intelligence. B is correct because crystallized intelligence reflects accumulated knowledge and verbal skills that tend to grow or hold steady with age, while fluid intelligence captures the ability to solve unfamiliar problems and tends to decline gradually, matching the woman's profile. A is wrong because episodic and semantic memory are categories of long-term memory content rather than the verbal knowledge versus novel problem-solving distinction described. C is wrong because procedural and declarative memory distinguish skills from facts, not the experience-based versus on-the-spot reasoning split shown by the test scores. D is wrong because top-down and bottom-up processing describe directions of perceptual influence, not age-related differences in verbal knowledge versus novel reasoning. Intelligence isn't a single thing. It comes in two broad forms that follow very different paths across the lifespan. Understanding what drives each one helps explain why aging affects some abilities more than others. Raymond Cattell proposed this two-factor distinction in the 1940s, and John Horn refined it in the 1960s. Crystallized intelligence reflects accumulated knowledge and vocabulary built through experience, while fluid intelligence reflects raw, on-the-spot reasoning about novel problems. Crystallized intelligence tends to grow or hold steady well into later life, because it builds on everything a person has learned and stored. Fluid intelligence peaks in early adulthood and declines gradually, because it depends on processing speed and working memory, resources that diminish with age. Crystallized intelligence loads on stored representations, vocabulary, factual knowledge, and well-practiced skills. Fluid intelligence loads on active cognitive operations, holding novel information in working memory, spotting abstract patterns, and flexibly shifting strategies when an approach fails. The signal words for this distinction are accumulated knowledge versus novel reasoning, and stable with age versus gradually declining. Don't confuse it with episodic versus semantic memory, or declarative versus procedural. Those are separate distinctions entirely. Question 11. A neuroscience class learns about classic experiments in which researchers recorded from individual neurons in the cat visual cortex while presenting bars of light at different orientations. The team discovered that some neurons fired only when an edge was tilted at a specific angle. Which finding does this describe? Your options are A. The discovery of mirror neurons, B. The principle of cortical equipotentiality, C. Hubel and Wiesel's feature detectors, D. Sparse coding in the auditory cortex. Before I reveal it, which one do you think is right? The correct answer is C. Hubel and Wiesel's feature detectors. C is correct because Hubel and Wiesel's recordings in cat visual cortex revealed neurons selectively tuned to specific edge orientations, the foundational evidence for feature detectors and early visual processing. A is wrong because mirror neurons fire when an action is performed and when the same action is observed, a different phenomenon discovered in motor cortex of macaques. B is wrong because cortical equipotentiality is a much older Lashley-era idea that brain regions are interchangeable, the opposite of localized feature detection. D is wrong because sparse coding describes a population-level coding scheme in which only a few neurons respond to any given stimulus, not the single neuron edge tuning discovered by Hubel and Wiesel. Feature detectors are specialized neurons in the visual cortex that respond selectively to specific properties of a visual stimulus, like edges at a particular angle or motion in a specific direction. This discovery fundamentally changed how scientists understand visual perception. Hubel and Wiesel identified 3 types of cortical neurons. Simple cells require an edge at a precise tilt and location. Complex cells are more flexible about position. End-stop cells add length tuning. The edge must also be the right size. The hierarchy works from the bottom up. Raw edges are detected in primary visual cortex, and as the signal travels to higher areas, neurons combine simpler features into increasingly abstract representations of the visual world. A striking feature of these neurons is their specificity. A single cortical neuron may stay completely silent while a bar of light is swept across the screen at every angle, then fire a rapid burst the instant that bar hits exactly the right tilt. The key insight is that the cortex does not passively mirror the retina. It actively breaks the visual world into elementary components. When you see single-cell recordings tuned for edge orientation, think Hubel and Wiesel's feature detectors. Question 12. A stroke patient produces fluent, grammatically smooth speech that nonetheless contains made-up words and conveys little meaning, and he struggles to understand what others say. An MRI shows damage to a region of the left temporal lobe. Which condition fits this picture? Your options are A. Wernicke's aphasia, B. Broca's aphasia, C. prosopagnosia, D. conduction aphasia. What's your answer? Commit to one before I continue. The correct answer is A. Wernicke's aphasia. A is correct because Wernicke's aphasia results from damage to the left temporal lobe and is characterized by fluent but semantically empty speech and impaired comprehension, exactly the patient's presentation. B is wrong because Broca's aphasia produces effortful, halting, grammatical speech with relatively preserved comprehension and is associated with frontal lobe damage rather than temporal lobe damage. C is wrong because prosopagnosia is a deficit in face recognition tied to damage in the fusiform face area, not a language disorder. D is wrong because conduction aphasia involves difficulty repeating words despite reasonable comprehension and fluent speech, and it does not match the empty fluent speech with impaired understanding pattern shown here. Wernicke's aphasia is a language disorder caused by damage to the left temporal lobe, specifically Wernicke's area. Unlike other aphasias, speech remains fluent and rhythmically normal, yet it carries little meaning and comprehension is severely impaired. The defining triad is fluent output, jargon-filled or meaningless content, and impaired understanding of both spoken and written language. Crucially, patients are often unaware of the deficit because the very system that monitors speech has been disrupted. Carl Wernicke described this syndrome in 1874, complementing Broca's 1861 discovery. Together they established that language production and comprehension rely on distinct cortical regions, Broca's area in the left frontal lobe and Wernicke's area in the left temporal lobe. The most common exam trap is confusing these disorders. Broca's aphasia produces effortful telegraphic speech with preserved comprehension. Conduction aphasia disrupts repetition despite intact production and comprehension. Prosopagnosia is a face recognition deficit entirely unrelated to language. When you see fluent but meaningless speech paired with poor comprehension, think left temporal lobe and Wernicke's area. That dissociation is one of the most foundational examples of cortical localization of function in all of neuropsychology. Question 13. A neuropsychology textbook presents case studies showing that damage to one circumscribed cortical region disrupts speech production, while damage to a different region disrupts speech comprehension, and damage to yet another region disrupts face recognition. Which broader principle do these dissociations support? Your options are A. Cortical equipotentiality, B. Hierarchical processing only, C. Synaptic pruning, D. Localization of function. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. Localization of function. D is correct because localization of function is the principle that specific cortical regions support specific cognitive operations, supported precisely by cases in which a focal lesion knocks out one ability while sparing others. A is wrong because cortical equipotentiality holds that brain tissue is interchangeable, the position contradicted by these dissociations. B is wrong because hierarchical processing describes how lower-level features are integrated into more complex representations across processing stages, not the region-specific deficits highlighted by case studies. C is wrong because synaptic pruning is a developmental process of eliminating excess synapses and is unrelated to the lesion-based dissociations being described. Localization of function is the principle that specific cognitive operations are tied to specific cortical regions. Damage to one area disrupts the function it supports, while leaving other functions intact. The cortex is organized so that different functions live at different addresses. Broca's area handles speech production, Wernicke's area handles comprehension, the occipital lobe processes vision, and specialized regions like the fusiform gyrus support face recognition. The experimental signature of localization is the dissociation. A simple dissociation is when a patient loses one ability but retains another. A double dissociation, two patients, each losing a different ability, is stronger evidence that two functions depend on entirely separate cortical regions. Localization stands in contrast to equipotentiality, the older idea that lesion effects depend only on how much brain is damaged, not where. Modern dissociation studies have largely overturned that view, though today we recognize that functions emerge from networks of regions, not single isolated spots. The key takeaway is that localization is a powerful first approximation supported by over a century of lesion studies and neuroimaging. When you see terms like focal damage, double dissociation, or region-specific deficit, think localization of function. Question 14. A sensory neuroscientist explains that a face is represented in the brain not by one solitary neuron, and not by all neurons firing equally, but by a small group of neurons that respond more strongly to that face than to others. Which type of neural coding is being described? Your options are A. Specificity coding, B. Sparse coding, C. Population coding using the entire network, D. Topographical mapping. Which would you go with? Lock it in before the reveal. The correct answer is B. Sparse coding. B is correct because sparse coding represents a stimulus through the activity of a relatively small subset of neurons, sitting between strict single-cell specificity coding and broad population coding. A is wrong because specificity coding posits a one-to-one match between a stimulus and a single neuron, sometimes called the grandmother cell idea, which is more extreme than the small group account. C is wrong because population coding distributed across the entire network would involve all neurons contributing, but the scenario specifies only a small group of neurons. D is wrong because topographical mapping refers to the orderly spatial arrangement of receptors in cortex, not a coding scheme for representing specific stimuli through subsets of neurons. Sparse coding is a representational strategy the brain uses to encode stimuli efficiently. Rather than relying on one dedicated neuron or the entire population, it recruits just a small, selective subset of neurons to carry the identity of a stimulus. Think of these as a spectrum. Specificity coding, sometimes called the grandmother cell hypothesis, assigns one neuron to one stimulus. Population coding spreads activation across the entire network. Sparse coding sits in the middle with a small but selective subset doing the work. In sparse coding, each neuron responds preferentially to a limited set of stimuli and stays silent otherwise. Different stimuli activate different small subsets, so the pattern of which neurons fire is what identifies the stimulus, not any single cell alone. Pure specificity coding is combinatorially impossible. We recognize far more stimuli than we have neurons. Pure population coding makes rapid identification harder. Sparse coding threads the needle. A small selective ensemble supports discrimination, handles vast stimulus sets, and remains robust to single neuron loss. When you see phrases like selective firing, concept cells, or medial temporal lobe neurons responding to a celebrity's face, that's sparse coding, not strict specificity, not full population coding. A small selective subset is the defining signature. Question 15. A research team rears kittens in an environment that contains only horizontal stripes for the first months of life. When tested later, the kittens show poor responses to vertical edges and have fewer cortical neurons tuned to vertical orientations. Which principle does this finding illustrate? Your options are A. Cortical equipotentiality, B. Functional connectivity, C. Experience-dependent plasticity, D. Sparse coding in the visual cortex. Don't overthink it. Which one feels right? The correct answer is C. Experience-dependent plasticity. C is correct because experience-dependent plasticity is the brain's capacity to reshape its neural circuitry according to the patterns of stimulation it actually receives, the mechanism behind the kitten's altered orientation tuning. A is wrong because cortical equipotentiality claims that any region can take over any function, a position not supported by orientation-specific changes driven by experience. B is wrong because functional connectivity describes how brain regions communicate during cognitive tasks rather than how individual cortical neurons gain their tuning preferences. D is wrong because sparse coding is a representational scheme, not the developmental rewiring process that produced the altered tuning in the kittens. Experience-dependent plasticity is the brain's lifelong capacity to physically rewire itself based on the specific patterns of stimulation it receives. Unlike fixed wiring views of the mature brain, modern neuroscience confirms that learning and environment drive structural change throughout life. The mechanism rests on activity-dependent synaptic modification. When neurons repeatedly fire together, long-term potentiation strengthens their connection. When activity is absent, long-term depression and pruning weaken or eliminate it, literally sculpting circuits from experience. This principle operates across the entire lifespan. From early visual cortex wiring in infants, to adult mastery of musical or athletic skills, to rehabilitation after stroke, where intensive practice recruits surrounding healthy tissue to restore lost function. On exams, watch for signal phrases like critical period, rearing in altered environments, and cortical reorganization. These all point to experience-dependent plasticity, activity-driven structural change, not to equipotentiality, hierarchical processing, or functional connectivity, which describe different phenomena entirely. Remember, experience-dependent plasticity is not limited to development. Wherever focused activity goes, structural change follows, making it the foundation of learning, recovery, and adaptation throughout life. Question 16. A graduate student presents pairs of three-dimensional block figures and asks participants to decide whether the second figure is the same shape as the first or a mirror image. She finds that response time increases linearly with the angle between the two orientations. Which classic study is being replicated? Your options are A. Shepard and Metzler's mental rotation experiment, B. Koslin's mental scanning study, C. Pavio's paired associate learning task, D. Sperling's partial report procedure. Got a guess? Lock it in. The correct answer is A. Shepard and Metzler's mental rotation experiment. A is correct because Shepard and Metzler reported that the time required to compare two block figures rose in direct proportion to the angular difference between them, evidence that mental rotation operates analogously to physical rotation. B is wrong because Koslin's mental scanning work measured time to scan between locations on an imagined map, not rotation of three-dimensional shapes. C is wrong because Pavio's paired associate learning examined how concrete and abstract words are remembered, not rotation of mental images. D is wrong because Sperling's partial report procedure measured iconic memory capacity using briefly presented letter arrays, a method unrelated to rotation tasks. Mental rotation is the cognitive operation of imagining an object turning through space. What makes it scientifically powerful is the precise, measurable signature it leaves in reaction time data. In their landmark 1971 study, Shepard and Metzler found that the further apart two figures were in orientation, the longer it took to decide if they matched. The relationship was strikingly linear, as though participants were mentally spinning the shape like a physical object. When results are plotted, the data points fall on a clean straight line. A small angular difference yields a fast response. A 180-degree difference takes roughly 3 times as long. This linear function is the diagnostic signature of mental rotation. Students often confuse mental rotation with related paradigms. Mental scanning, linked to Koslin, uses imagined maps and distance effects. Paired associate learning, linked to Pavio, studies imagery and word memory. Iconic memory, linked to Sperling, measures brief sensory persistence. Only mental rotation produces the linear angle-to-response time function with 3D shapes. Whenever an exam stem describes comparing rotated three-dimensional figures with reaction time scaling proportionally to the angle of difference, that is Shepard and Metzler's mental rotation paradigm, not scanning, not imagery and memory, not sensory persistence. Question 17. An undergraduate is asked to memorize a fictional island map showing a hut, a tree, a beach, and a lake at different distances from one another. He then closes his eyes and is asked to focus on the hut and signal when he reaches the tree, the beach, or the lake. His response times scale with the actual distances on the map. Which finding does this support? Your options are A. Atkinson and Shiffrin's modal model, B. The phonological similarity effect, C. The garden path model of passing, D. Koslin's mental scanning paradigm. Which one is it? Pause the video if you need more time. The correct answer is D. Koslin's mental scanning paradigm. D is correct because Koslin's mental scanning experiments demonstrated that the time to traverse an imagined space correlates with the actual distance on the studied map, supporting depictive imagery that preserves spatial structure. It is wrong because the Atkinson and Shiffrin modal model is about the flow of information through sensory, short-term, and long-term stores, not about scanning mental images. B is wrong because the phonological similarity effect concerns confusions between similar sounding words in short-term memory, not visual scanning of imagined maps. C is wrong because the garden path model describes how readers parse syntactically ambiguous sentences, an entirely different topic from imagery. Mental scanning is the cognitive operation of moving attention across a remembered visual scene, much like traversing a real physical space. The key insight is that the time it takes to scan between two remembered locations grows with the actual distance between them on the original. In Koslin's classic studies, participants first memorized a fictional island map with landmarks like a hut, a lake, and a beach. With eyes closed, they mentally scanned from one landmark to another, signaling when their attention arrived. Crucially, the time taken tracked the real distances on the map. Two competing theories were at stake. A propositional account treats mental representations as abstract symbol lists. Predicting scan time should depend on list length. A depictive account holds that images preserve real spatial geometry, predicting scan time scales with distance. Koslin's data decisively supported the depictive side. Mental scanning isn't just behavioral, it has a neural signature. The same early visual cortex regions active during real perception are recruited during imagery. Transcranial magnetic stimulation disrupting visual cortex also disrupts imagery tasks, confirming that imagery and perception share core representational machinery. The takeaway is straightforward. Whenever a paradigm describes participants traversing an imagined space and producing reaction times that scale with original physical distance, that's Koslin's mental scanning, not mental rotation, not paired associate learning. Question 18. A memory researcher pairs concrete, easily imaged words like elephant with abstract words like truth and test recall. He finds that the concrete words act as mental hooks for the abstract partners, boosting recall. Which hypothesis does this finding support? Your options are A. The phonological loop hypothesis, B. Pavio's conceptual peg hypothesis, C. The encoding specificity principle, D. The reminiscence bump. Take a second. Which answer would you pick? The correct answer is B. Pavio's conceptual peg hypothesis. B is correct because Pavio's conceptual peg hypothesis proposes that concrete, easily imaged words act as mental pegs that anchor and recall paired abstract items, exactly the boost the researcher observed. A is wrong because the phonological loop hypothesis is part of Baddeley's working memory model and concerns rehearsal of verbal information rather than visual imagery's role in long-term recall. C is wrong because encoding specificity holds that retrieval improves when context at recall matches encoding context, a separate principle that does not require imagery. D is wrong because the reminiscence bump is an autobiographical memory finding about life period recall, not the role of imagery in paired associate learning. The conceptual peg hypothesis, developed by Alan Pavio, explains why some words work far better than others as memory cues in paired associate learning. The key variable isn't how common or familiar a word is, it's how easily you can picture it. The hypothesis sits inside Pavio's dual coding theory, which holds that the brain stores information in two complementary systems. When a word activates both a verbal and an imagery code simultaneously, it becomes far easier to remember than a word represented in only one system. When a concrete cue word like elephant is presented, a vivid mental image forms naturally, and the paired target word gets anchored to that image like an object hung on a peg. When the cue is abstract, like truth, no image materializes, the hook never forms, and the target word has nothing to hold it in memory. Pavio's experiments systematically crossed the imageability of cue and target words. The clearest finding was that imageable cues produce the greatest recall advantage, confirming that imagery is actively doing memory work, not simply accompanying it. Whenever an exam stem describes concrete words anchoring abstract words in paired associate learning, that's the conceptual PEG hypothesis. Don't confuse it with the method of Lotzi, elaborative rehearsal, or the phonological loop. Those are distinct mechanisms with distinct claims. Question 19. A theoretical debate in cognitive psychology asks whether mental images are stored as picture-like representations that preserve spatial layout, or as abstract symbolic statements that simply describe spatial relationships. Which contrast captures this debate? Your options are A. Episodic versus semantic memory, B. Bottom-up versus top-down processing, C. Depictive versus propositional representations, D. Maintenance versus elaborative rehearsal. Before I reveal it, which one do you think is right? The correct answer is C. Depictive versus propositional representations. C is correct because the depictive versus propositional debate centers on whether mental images preserve spatial structure visually or merely encode relationships in language like propositions the framing the question describes. A is wrong because the episodic versus semantic distinction concerns types of long-term memory content rather than the format of mental images. B is wrong because bottom-up versus top-down captures the direction of perceptual processing, not the format of imagined representations. D is wrong because maintenance versus elaborative rehearsal describes two strategies for keeping information in mind, not the picture-like versus symbolic format dispute. One of the longest-running debates in cognitive psychology concerns the format of mental images. Not whether we have them, but what kind of internal representation underlies them. Koslin's depictive view holds that images preserve actual geometric relationships, like a picture in the head. Pilishin's propositional view holds that images are abstract symbol structures, and descriptions that merely simulate spatial properties when read out. The striking thing is that classic experiments, mental rotation time scaling with angle, scanning time scaling with distance, were consistent with both accounts. The behavioral data alone could not distinguish a picture-like representation from an abstract symbolic one that mimics its timing. Neuroimaging shifted the debate toward the depictive side, but did not end it. Pilishin argues that demand characteristics and tacit knowledge about how spatial tasks feel can produce the same patterns without any picture-like representation in the brain. This debate is specifically about the format of mental images, not types of memory, not perceptual direction. When a question asks whether imagery preserves spatial structure or encodes it symbolically, depictive versus propositional is the exact framework you need. Question 20. A student preparing for a biology exam mentally walks through the rooms of his apartment, depositing each anatomical term at a specific spot in the kitchen, the living room, and the bedroom. During the exam, he mentally retraces his path to retrieve each term. Which mnemonic technique is he using? Your options are A. The method of Lotzi, B. Articulatory suppression, C. The savings method, D. Maintenance rehearsal. What's your answer? Commit to one before I continue. The correct answer is A. The method of Lotzi. A is correct because the method of loci pairs items to be remembered with familiar physical locations along a mental route, allowing the learner to retrieve the items by walking through the route again. B is wrong because articulatory suppression involves repeating an irrelevant sound to block subvocal rehearsal, the opposite of an aid to memory. C is wrong because the savings method, introduced by Ebbinghaus, measures how much faster relearning is compared to original learning, not a strategy for organizing new information. D is wrong because maintenance rehearsal repeats material silently to keep it active in short-term memory, but does not link items to spatial locations as the method of loci does. The method of loci is one of the oldest and most powerful mnemonic techniques ever devised. It works by harnessing your brain's naturally strong spatial memory to carry information that would otherwise be hard to hold on to. The technique rests on three interlocking properties. A familiar spatial route provides a stable, ordered framework. Placing items there forces elaborative encoding through vivid mental images, and at retrieval, each location automatically reactivates the image deposited there. Imagine walking through your apartment. At each room you plant one vivid image tied to what you need to remember. Later, mentally retracing that same path lets you pick up each item in order, converting a weakless memory task into a strong spatial navigation task. Don't confuse the method of loci with related strategies. The keyword method links foreign words to similar sounding English words. The peg system hooks items to number rhyme pairs. Maintenance rehearsal simply repeats material in short-term memory without producing strong long-term encoding. Traced back to the poet Simonides of ancient Greece and validated by modern memory research, the method of loci remains uniquely effective. When an exam stem describes mentally walking through rooms and placing items at specific spots, that is your signal. Method of loci. Question 21. An eye tracking study shows that adult readers fixate longer on the word salient than on the word happy, even when the words appear in similar sentence context. The researchers attribute this to how often each word appears in everyday text. Which phenomenon best explains the pattern? Your options are A. The phonological similarity effect, B. The word frequency effect, C. The garden path effect, D. The illusionary truth effect. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B. The word frequency effect. B is correct because the word frequency effect refers to faster, easier processing of high-frequency words and slower processing of low-frequency words, indexed in eye tracking by shorter or longer fixation durations. A is wrong because the phonological similarity effect concerns confusions among similar sounding items in short-term memory, not the time required to recognize printed words. C is wrong because the garden path effect describes reanalysis costs when an initial pass turns out to be wrong, a syntactic phenomenon rather than a lexical frequency effect. D is wrong because the illusionary truth effect is a memory phenomenon in which repeated statements feel more believable, unrelated to fixation duration on individual words. The word frequency effect is one of the most replicated findings in psycholinguistics. It describes why common words are recognized faster than rare ones, and it shows up across multiple experimental methods. Researchers measure the effect three ways: lexical decision tasks, where participants judge whether a letter string is a word; eye tracking, which records how long readers fixate each word; and naming latency. All three converge on the same result: high-frequency words are processed faster in Rayner and Duffy's 1986 eye tracking work. Readers fixated low-frequency words significantly longer, often 20 to 40 milliseconds more, even within ordinary sentences where length and predictability were held constant. The mechanism involves activation thresholds in the mental lexicon. Words you encounter often maintain higher resting activation, so they need less perceptual input to be recognized. Rare words start lower and require more evidence to push them over the threshold. The word frequency effect is specifically about single word recognition speed. It's distinct from the phonological similarity effect in short-term memory, the garden path effect in syntax, and the illusory truth effect in memory. The signal words are fixation, duration, lexical decision, and Rayner and Duffy. Question 22. A student reads the sentence, "The bank was busy that morning," and almost always interprets bank as a financial institution rather than the side of a river, even though both meanings are grammatical. Which property of the word bank explains the pattern? Your options are A. Word length effects, B. Phonological similarity, C. Syntactic priming, D. Biased dominance among ambiguous meanings. Which would you go with? Lock it in before the reveal. The correct answer is D. Biased dominance among ambiguous meanings. D is correct because a lexically ambiguous word with biased dominance has one meaning that is much more common than the other, so readers default to that dominant interpretation unless context clearly points elsewhere. A is wrong because the word length effect concerns how longer words are harder to rehearse in short-term memory, not how readers select among meanings of an ambiguous word. B is wrong because phonological similarity concerns sound-based confusions in working memory and does not explain meaning selection during reading. C is wrong because syntactic priming is the tendency to reuse previously encountered sentence structures, not a property of word meaning frequency. When a single word carries more than one meaning, psycholinguists ask, which meaning does the brain choose first, and why? The answer depends on a property called dominance, how evenly the meanings of an ambiguous word are distributed in everyday language use. A biased ambiguous word like bank has one overwhelmingly common meaning, the financial institution, and a much rarer one. A balanced ambiguous word like ball has two meanings, a sphere and a formal dance, that compete on roughly equal footing. In the mental lexicon, the dominant meaning of a biased word has a higher resting activation level. When bank is read with no disambiguating context, the financial meaning surges past the recognition threshold first. For ball, both meanings remain active simultaneously, and the reader waits for further context to resolve the competition. Word frequency is about how often a word itself appears in language. Biased dominance is about how often one meaning appears relative to another meaning of the same word. Syntactic priming is a completely different effect, the tendency to reuse recently heard sentence structures. These operate at different levels of language processing. When a question describes a reader automatically defaulting to one interpretation of an ambiguous word, that's biased dominance at work. When both interpretations linger until context arrives, that's balanced dominance. Keeping these distinct from general word frequency and syntactic priming is what separates correct answers from common exam mistakes. Question 23. A researcher presents the sentence, "The horse raced past the barn fill," and finds that participants pause and then reread when they reach fill. The initial pass treats raced as the main verb and breaks down at fill, forcing reanalysis. Which model best explains this pattern? Your options are A. The garden path model of parsing, B. The conceptual peg hypothesis, C. The encoding specificity principle, D. The word frequency effect. Don't overthink it. Which one feels right? The correct answer is A. The garden path model of parsing is correct because the garden path model holds that readers commit early to the simplest pass and then must reanalyze when later words contradict the initial structure. Exactly what happens at fill in this sentence. B is wrong because the conceptual peg hypothesis concerns how concrete imagery anchors paired associate learning, not syntactic parsing. C is wrong because encoding specificity is a memory principle about matching context at encoding and retrieval, unrelated to sentence parsing. D is wrong because The word frequency effect concerns ease of word recognition rather than the syntactic reanalysis triggered by an unexpected verb. The garden path model explains how readers process sentences in real time by committing early to the simplest syntactic structure available. When that initial pass turns out to be wrong, the reader must stop and reanalyze. The model takes its name from the phrase being led down the garden path. The reader follows the most plausible route through a sentence, only to hit a dead end when later words contradict that structure. The classic example is the horse raced past the barn, fell. Readers initially treat raced as the main verb, but when fell appears, that pass collapses. The passer must rebuild the sentence, recognizing race past the barn as a reduced relative clause, with fell as the actual main verb. Fraser's model rests on two parsing strategies. Minimal attachment favors the structurally simplest pass, and late closure attaches incoming material to the most recently built clause. These heuristics succeed most of the time but break down when a simpler initial structure is incompatible with the rest of the sentence. What makes a sentence a garden path is not difficulty in general, but the specific pattern of an early structural commitment that collapses when new information arrives, forcing effortful reanalysis. Question 24. An infant listening to fluent speech in an unfamiliar language gradually figures out where one word ends and the next begins. Researchers find that the baby is sensitive to which sounds tend to follow, which other sounds, treating low probability transitions as likely word boundaries. Which mechanism is the infant using? Your options are A. Articulatory suppression, B. Permission schema, C. Statistical learning of transitional probabilities, D. Top-down lexical priming. Got a guess? Lock it in. The correct answer is C. Statistical learning of transitional probabilities. C is correct because Safran and colleagues showed that infants segment continuous speech by tracking transitional probabilities, with dips in transition likelihood signaling probable word boundaries. A is wrong because articulatory suppression is a manipulation that blocks rehearsal in working memory studies, not a real-world segmentation mechanism. B is wrong because permission schemas are reasoning structures applied to conditional rules in tasks like the Wason card problem, unrelated to speech parsing. D is wrong because lexical priming requires existing word knowledge to spread activation, but the infant in the scenario does not yet know the words and is relying on raw statistical regularity. When we listen to speech, words seem to arrive with clear boundaries between them. But that's an illusion. Continuous speech contains almost no reliable acoustic pauses at word edges. So how do infants figure out where one word ends and the next begins? A spectrogram of natural speech looks like one unbroken signal. The gaps we perceive as listeners aren't really there. We impose them. Infants, who don't yet know any words, can't rely on vocabulary knowledge. So they need another strategy entirely. Within a word, one sound reliably follows another. Transitional probability is high, but at word boundaries, the next sound could belong to many different words, so probability drops. Infants track these dips in transitional probability to discover where words begin and end. Jenny Safran and colleagues demonstrated this in a landmark 1996 study. After just 2 minutes of passive listening, 8-month-old infants could distinguish the original nonsense words from new sequences with the same syllables in different orders. Evidence of pure statistical learning. Statistical learning is a bottom-up process. No word knowledge required. Infants extract word boundaries simply by tracking which sound-to-sound transitions are probable versus improbable, making it a powerful early tool for cracking the code of continuous speech. Question 25. A reader processes the sentences, Maria forgot her umbrella. She got soaked walking home, Without conscious effort, the reader connects she to Maria. Which type of inference is the reader making? Your options are A. Instrument inference, B. Anaphoric inference, C. Pragmatic inference about a speaker's intent, D. Causal inference between sentences. Which one is it? Pause the video if you need more time. The correct answer is B. Anaphoric inference. B is correct because anaphoric inference links a pronoun or noun phrase to its referent earlier in the text, exactly the operation that ties she back to Maria. A is wrong because instrument inference fills in implied tools or methods, such as inferring that someone hammered a nail with a hammer, not pronoun resolution. C is wrong because pragmatic inference draws on social or world knowledge to interpret a speaker's intent, broader and more context-dependent than simple coreference. D is wrong because causal inference connects events through cause and effect, but the question is specifically about which earlier referent the pronoun she points to. Anaphoric inference is the mental operation of linking a pronoun or referring expression back to a previously mentioned entity. It's what allows language to flow without repeating names over and over. Here, the pronoun she must be linked back to Maria, the antecedent introduced in the prior sentence. Grammatical features like gender and number, plus Maria's prominence in the discourse, converge to make this link fast and effortless. Resolution works by narrowing down candidate reference using three types of constraints: grammatical features like gender and number, semantic fit with the predicate, and discourse factors like recency and topical prominence. When all three converge, resolution is instant. The key exam distinction is recognizing that anaphoric inference is specifically about linking referring expressions to prior entities. It's main not inferring tools, speaker intent, or causal chains. Each type has its own signal words, and mixing them up is the most common mistake. Whenever you see a pronoun or noun phrase being tied back to a previously introduced entity, that's anaphoric inference, the engine that keeps discourse coherent and character tracking continuous. Question 28. A psychology textbook describes a memory framework with three sequential stores: a brief sensory register, a limited capacity short-term store where rehearsal occurs, and a vast long-term store from which information can later be retrieved. Which classic model is being summarized? Your options are A. Baddeley and Hitch's working memory model, B. Tulving's mental time travel framework, C. Levels of processing theory, D. Atkinson and Shiffrin's modal model. Take a second. Which answer would you pick? The correct answer is D. Atkinson and Shiffrin's modal model. D is correct because the Atkinson and Shiffrin modal model lays out the three stores in exactly that order, with rehearsal as the mechanism that moves information from short-term to long-term storage. A is wrong because Baddeley and Hitch's working memory model is a refinement of the short-term component, with subsystems like the phonological loop, but does not itself describe the full three-store flow. B is wrong because Tulving's mental time travel concept refers to the subjective re-experiencing of past events, a property of episodic memory rather than a structural model. C is wrong because levels of processing theory focuses on depth of encoding rather than discrete stores, in fact rejecting structural store metaphors. The Atkinson and Shiffrin modal model, published in 1968, gave cognitive psychology its first unified structural account of how information moves through the mind. It synthesizes decades of memory research into a single elegant flow. Sensory memory briefly captures incoming input. If attention is paid, that information enters short-term memory, which holds roughly 7 items for seconds. Rehearsal is the critical gateway. Items repeated enough get transferred into long-term memory, which holds information for years with virtually unlimited capacity. The model synthesized 3 landmark findings. Sperling's iconic memory studies revealed a brief high-capacity visual buffer. Miller's magical number 7 paper defined short-term limits. And patient HM showed that short-term and long-term memory are anatomically distinct systems. Rehearsal is the engine of the modal model. Repeating an item keeps it alive in short-term memory, and enough repetition pushes it into long-term storage. Without rehearsal, limited capacity means incoming information simply displaces what came before. Don't confuse the modal model with its successors. Baddeley and Hitch broke STM into subsystems. Tulving focused on episodic re-experiencing. Crack and Lockhart replaced stores with depth of encoding. Only Atkinson and Schifrin proposed the original 3-store flow with rehearsal as the transfer mechanism. Question 29. A researcher briefly flashes a 3x4 array of letters and then sounds a tone immediately after to indicate which row to report. Participants report the cued row almost perfectly, but if the tone is delayed by 1 second, performance collapses. Which classic finding is being demonstrated? Your options are A. Sperling's partial report and the rapid decay of iconic memory. B. The serial position curve in long-term memory. C. Articulatory suppression in the phonological loop. D. The word length effect in short-term memory. Before I reveal it, which one do you think is right? The correct answer is A. Sperling's partial report and the rapid decay of iconic memory. A is correct because Sperling's partial report procedure showed that a brief, high-capacity visual icon holds the entire array for a fraction of a second and decays rapidly within roughly a second, matching the pattern in the question. B is wrong because the serial position curve plots recall accuracy against item position in a list and addresses long-term and short-term memory together, not iconic decay. C is wrong because articulatory suppression blocks subvocal rehearsal and reduces phonological similarity effects, but it is not the mechanism behind the partial report finding. D is wrong because the word length effect concerns how long words are harder to rehearse, not the rapid decay of a visual sensory store. Iconic memory is a brief, high-capacity visual sensory store that holds a snapshot of what you just saw. George Sperling's 1960 partial report experiment gave us our clearest window into how the store works and how quickly it fades. Earlier researchers used whole report, show a grid of letters, recall as many as possible. People could only report 4 to 5 letters, no matter how many were shown. Sperling suspected this was a readout bottleneck, not a true storage limit. After the letter array flashes, a tone tells the participant which row to report. At very short delays, accuracy is nearly perfect for the cued row, implying most of the 12 letters were still available. As the delay stretches toward 1 second, that advantage vanishes entirely. Iconic memory is specifically visual and sensory. It is not the same as working memory, which is capacity limited and rehearsal based. Its defining features are high initial capacity and extremely rapid decay, with no role for verbal rehearsal. On an exam, if you see partial report, brief visual flash, or decay across milliseconds, that is iconic memory and Sperling. Don't confuse it with the serial position curve, articulatory suppression, or the word length effect. Those belong to different memory systems entirely. Question 28. A working memory researcher explains that one component of the system rehearses verbal information through subvocal speech and stores recently heard sounds for a few seconds. Which subsystem of Baddeley's model is being described? Your options are A. Visuospatial sketchpad, B. Phonological loop, C. Episodic buffer, D. Central executive, What's your answer? Commit to one before I continue. The correct answer is B. Phonological loop. B is correct because the phonological loop is the verbal subsystem of working memory, responsible for storing speech-based information briefly and refreshing it through sub-vocal rehearsal. A is wrong because the visuospatial sketchpad handles visual and spatial information, not verbal rehearsal. C is wrong because the episodic buffer integrates information from multiple sources into a unified representation, but does not specialize in subvocal verbal rehearsal. D is wrong because the central executive coordinates the subsystems and allocates attention, rather than storing or rehearsing verbal material itself. The phonological loop is the verbal subsystem of Baddeley and Hitch's 1974 working memory model. It temporarily holds speech-based information and keeps it alive through a process called subvocal rehearsal, silently repeating words in your head like inner speech. The loop has two parts. The phonological store holds incoming auditory or speech-coded material for roughly 2 seconds before it fades. The articulatory rehearsal process reads that material back as inner speech, refreshing it and preventing decay. When you hear a word, it enters the phonological store directly. When you read a word, it is first recoded into a sound-based form. The articulatory rehearsal process then continuously loops material back into the store, like a tape that rewinds before it runs out. Baddeley and Hitch proposed working memory has multiple components because verbal and visual information use separate resources. The phonological loop handles verbal material only. The visuospatial sketchpad handles visual and spatial information. The episodic buffer integrates across sources, and the central executive coordinates everything. On exams, watch for signal words like subvocal rehearsal, inner speech, phonological store, and verbal short-term memory. These all point to the phonological loop, not the sketchpad, the episodic buffer, or the central executive. Question 29. A researcher gives participants 2 short word lists to recall in order. List 1 contains words that sound alike: cat, mat, bat, hat, sat. List 2 contains unrelated words: pen, sky, jar, tin, dog. Recall is markedly worse on list 1. Which effect is being demonstrated? Your options are A. Word length effect, B. Self-reference effect, C. Phonological similarity effect, D. Generation effect. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is C. Phonological similarity effect. C is correct because the phonological similarity effect captures the finding that lists of similar sounding words are harder to recall in order than lists of dissimilar sounding words. Evidence that the phonological loop encodes by sound. A is wrong because the word length effect concerns the difficulty of recalling longer rather than similarly sounding words. B is wrong because the self-reference effect describes improved recall when material is related to the self, not the impact of phonological overlap. D is wrong because the generation effect involves better memory for self-generated information, irrelevant to the comparison of acoustically similar versus dissimilar lists. The phonological similarity effect reveals something fundamental about how verbal information is stored in short-term memory. It tells us that the working memory system encodes spoken and written words using a sound-based code, not a visual or semantic one. Compare 2 lists, one where every word rhymes and one where the words sound completely different. People consistently scramble the order of the rhyming list, even though the words themselves are unrelated in meaning. The confusion is purely about shared sound features. Inside Baddeley and Hitch's working memory model, visually presented words are converted into a sound-based code and held in the phonological store. When multiple items share phonological features, their memory traces overlap and interfere, making it impossible to reliably reconstruct the original order at recall. A common exam mistake is conflating the phonological similarity effect with related phenomena. The word length effect is about rehearsal time for longer words. The self-reference and generation effects are long-term memory findings. Phonological similarity is specifically about sound-based confusion in verbal short-term memory. Whenever a question describes rhyming or acoustically similar lists being harder to recall in order than dissimilar lists, the answer is the phonological similarity effect, one of the clearest windows into how the phonological loop operates. Question 30. A psychology lab manipulates working memory by asking participants to repeat the syllable the out loud while they try to memorize a word list. The repetition blocks subvocal rehearsal and reduces normal phonological loop effects. Which manipulation is being used? Your options are chunking, B. Maintenance rehearsal, C. The savings method, D. Articulatory suppression. Which would you go with? Lock it in before the reveal. The correct answer is D. Articulatory suppression. D is correct because articulatory suppression involves continuously vocalizing an irrelevant sound, which occupies the articulatory rehearsal mechanism and thereby disables the phonological loop's normal contribution to working memory. A is wrong because chunking is a strategy that groups items into meaningful units to expand effective short-term capacity, the opposite of an interference manipulation. B is wrong because maintenance rehearsal refers to repeating material silently to retain it, the very process that articulatory suppression blocks. C is wrong because the savings method measures relearning efficiency over time and is unrelated to manipulating the phonological loop online. Articulatory suppression is a technique where participants repeat an irrelevant sound out loud while memorizing something else. It's one of the most powerful tools in working memory research because it targets a very specific part of the system. The phonological loop has two parts, a store that holds sound-based memory traces and a rehearsal process that refreshes them. Articulatory suppression works by keeping the rehearsal process busy with irrelevant speech, so it can't do its normal job. When a participant says the continuously, the articulatory machinery is already occupied. Items in the phonological store can't be refreshed and decay rapidly. For visually presented words, suppression also blocks the recoding step that converts what you see into a sound-based representation. The key prediction of the working memory model is that if rehearsal drives both the phonological similarity effect and the word length effect, blocking rehearsal should collapse both, and it does. This is exactly what makes articulatory suppression such compelling evidence for the model. Articulatory suppression is specifically a verbal interference manipulation targeting rehearsal, not chunking, which groups items to expand capacity, not maintenance rehearsal, which is the silent repetition it blocks, and not the savings method, which measures long-term memory relearning. Question 31. A student studies a 20-item word list and is asked to recall the items in any order. Recall is highest for the first few items and the last few items, with the middle of the list remembered worst. Which pair of effects is the student showing? Your options are A. Primacy and recency effects in the serial position curve, B. Encoding specificity and the testing effect, C. Self-reference effect and generation effect, D. Reminiscence bump and youth bias. Don't overthink it. Which one feels right? The correct answer is A. Primacy and recency effects in the serial position curve. A is correct because the serial position curve shows a primacy advantage at the start of a list and a recency advantage at the end, with the middle items recalled most poorly, exactly the pattern described. B is wrong because encoding specificity and the testing effect describe how context and retrieval practice strengthen memory, not list position effects. C is wrong because the self-reference and generation effects are encoding manipulations that improve memory generally, not effects tied to position within a single list. D is wrong because the reminiscence bump and youth bias are autobiographical memory patterns across the lifespan, not within list effects. The serial position curve captures a fundamental truth about how we remember lists. When free recall accuracy is plotted against each item's position in a studied list, a distinctive U-shape emerges every time. First described in classic form by Bennett Murdoch in 1962, the curve has been replicated thousands of times. High accuracy at the start, a long low region in the middle, and a spike at the end. The shape is remarkably consistent. Two distinct mechanisms drive the two ends. Early items benefit from rehearsal before competing items arrive, pushing them into long-term memory. Recent items are still fresh in short-term memory at the moment of recall. Middle items enjoy neither advantage. The curve became theoretically powerful because researchers could manipulate one end independently. A 30-second arithmetic task filled between the last item and recall displaces short-term memory contents, eliminating recency while leaving primacy untouched, a clean dissociation between two memory stores. Remember, the serial position curve is specifically about position effects within a single studied list. It is not the Ebbinghaus forgetting curve, not the reminiscence bump. The signal words are free recall, list position, primacy, recency, and Murdoch. Question 32. A neuropsychologist studies a patient who can no longer recall any specific events from his life, yet can still describe how a microwave works, recite state capitals, and define vocabulary words. Which dissociation does the case illustrate? Your options are A. Implicit versus explicit memory. B. Working memory versus long-term memory. C. Impaired episodic memory with preserved semantic memory. D. Procedural memory loss with intact recognition. Got a guess? Lock it in. The correct answer is C. Impaired episodic memory with preserved semantic memory. C is correct because episodic memory stores personally experienced events with their context, while semantic memory stores general factual knowledge. A loss of personal events with preserved facts is a classic episodic versus semantic dissociation. A is wrong because the implicit versus explicit contrast involves conscious versus unconscious memory, not the personal event versus general knowledge split shown here. B is wrong because working memory is the short-term storage system. The patient's deficit is across decades of past events, which falls within long-term memory. D is wrong because procedural memory covers skills and habits, and the case does not describe loss of skills like riding a bike or typing. Within long-term declarative memory, Endel Tulving identified two distinct systems in 1972 that have shaped memory research ever since. Understanding what separates them and what brain structures support each is the core of this concept. Episodic memory encodes specific experiences: your first day at a new job, a birthday party last year. Semantic memory encodes facts: the capital of France, the boiling point of water. The felt quality of retrieval differs sharply between them. The strongest evidence for two distinct systems comes from neurological dissociations. Hippocampal damage wipes out new episodic memories while leaving semantic knowledge largely intact. Semantic dementia, caused by lateral temporal damage, does the opposite, eroding facts while sparing personal event recall. The episodic semantic distinction lives specifically inside explicit declarative long-term memory. It is not about conscious versus unconscious access, not about temporary versus permanent storage, and not about facts versus motor skills. Keep these four distinctions cleanly separated. When you see phrases like mental time travel, time and place, or personally experienced, think episodic. When you see general knowledge with no personal context, think semantic. The double dissociation in brain-damaged patients confirms these are genuinely separate systems. Question 33. An older adult who cannot recall meeting his physical therapist last week nonetheless improves at riding a stationary bike across daily sessions, getting smoother and more efficient over time. Which type of memory is supporting his improvement? Your options are A. Episodic memory, B. Procedural memory, C. Autobiographical memory, D. Working memory. Which one is it? Pause the video if you need more time. The correct answer is B. Procedural memory. B is correct because procedural memory stores motor and cognitive skills that improve with practice and is largely independent of conscious recollection, which is why the patient improves at biking despite no episodic memory of the sessions. A is wrong because episodic memory would let him recall the actual sessions, which is exactly what he cannot do. C is wrong because autobiographical memory blends episodic and semantic memory about one's own life, also dependent on conscious recall and not the system improving his motor skill. D is wrong because working memory holds information temporarily during a single task and does not accumulate skill across days. Procedural memory is the system that stores skills, the kind of knowledge that shows up as smooth performance rather than conscious recall. It operates largely outside awareness, and it follows very different rules than memorizing facts or personal events. Procedural and declarative memory are dissociable systems. A patient can lose the ability to form new episodic memories, yet still acquire new motor skills across days of practice. Use because skill learning depends on the basal ganglia and cerebellum, not the hippocampus. Henry Molaison, known as HM, could not recall a single mirror tracing session, yet his accuracy improved every day. His procedural memory was intact even though his declarative memory was devastated. The improvement was real, measurable, and unconscious. This diagram captures the core dissociation. Repeated practice drives measurable skill improvement through intact basal ganglia circuits, even when the hippocampus cannot form any memory of the training sessions themselves. When you see skill learning, mirror tracing, motor performance, or an amnesic patient getting better with practice, that is procedural memory, not episodic, not autobiographical, not working memory. Procedural memory specifically supports the gradual sharpening of skill without conscious recollection of practice. Question 34. A famous neurological case involves a patient who underwent bilateral surgical removal of a medial temporal lobe structure to control epilepsy. Afterward, he was unable to form new long-term episodic memories, although his short-term memory and motor skill learning remained intact. Which brain structure was removed? Your options are A. Cerebellum, B. Wernicke's area, C. Visual cortex, D. Hippocampus. Take a second. Which answer would you pick? The correct answer is D. Hippocampus. D is correct because the hippocampus is essential for the consolidation of new declarative memories, and its bilateral loss leaves working memory and procedural learning intact while devastating new episodic memory formation. A is wrong because the cerebellum supports motor coordination and some forms of associative learning, not the formation of new episodic memories. B is wrong because Wernicke's area is involved in language comprehension. Damage there causes a fluent receptive aphasia, not a memory consolidation deficit. C is wrong because the visual cortex processes visual information. Its removal would devastate vision, not episodic memory formation. The hippocampus is a curved structure deep in the medial temporal lobe, and it plays a central role in one of the most fundamental processes in cognitive neuroscience, turning new experiences into lasting memories. Bilateral hippocampal damage produces a striking dissociation. Short-term memory and procedural learning, like improving on a motor task, remain intact, but the ability to form new declarative memories for facts and events is devastated. This is called anterograde amnesia. The hippocampus acts as a binding hub. The cortex stores individual elements of an experience, the sights, sounds, emotional tone, and context. The hippocampus links these into a single unified episode over time. With repeated retrieval, those cortical representations become independent of the hippocampus, which is why older memories survive hippocampal damage. A common exam trap is attributing anterograde amnesia to the wrong structure. The cerebellum handles motor coordination. The visual cortex handles sight, and Wernicke's area handles language comprehension. Only bilateral hippocampal damage produces the specific pattern of lost declarative memory with preserved short-term and motor learning. When an exam stem describes preserved short-term memory and motor learning alongside an inability to form new long-term memories, tsuad, especially after bilateral medial temporal lobe surgery. Das ist kein Tweet. The hippocampus is always the answer. Henry Molaison's case remains the foundational evidence for this principle. Question 35. A researcher gives one group of participants the task of judging whether each studied word is printed in capital letters, while a second group is asked to decide whether each word fits into a sentence. Later, the second group recalls many more words. Which theoretical account best explains the difference? Your options are A. Levels of processing theory, in which deeper meaning-based encoding produces stronger memory. B. Encoding specificity, in which retrieval cues match study cues. C. The testing effect, in which retrieval practice strengthens memory. D. The phonological similarity effect within working memory. Before I reveal it, which one do you think is right? The correct answer is A. Levels of processing theory, in which deeper meaning-based encoding produces stronger memory. A is correct because Craik and Lockhart's levels of processing theory holds that deeper, semantic processing of material produces more durable memory than shallow. Surface feature processing, exactly the contrast the experiment manipulates. B is wrong because encoding specificity addresses the match between encoding and retrieval context, not the depth of initial processing. C is wrong because the testing effect requires participants to retrieve material between study and final test, not the initial task manipulation described. D is wrong because the phonological similarity effect operates within short-term verbal memory, not long-term recall driven by depth of meaning. Levels of processing theory, introduced by Craik and Lockhart in 1972, proposes that how well we remember something depends not on how long we study it, but on how deeply we process its meaning at encoding. Processing exists on a continuum. Shallow processing focuses on surface features like letter case or visual form. Phonological processing engages sound and rhyme. Semantic processing engages meaning, category membership, and connections to prior knowledge, and it produces the strongest, most durable memory traces. When researchers equate the time spent on each word but vary the type of encoding task, a clear gradient emerges. Participants who judge visual features recall the fewest words. Those who judge meaning recall 2 to 3 times as many, even though study duration was identical. A common exam trap is confusing levels of processing with related but distinct principles. Encoding specificity is about context match at retrieval, not encoding depth. The testing effect requires retrieval practice. The phonological similarity effect operates in short-term memory. Levels of processing is solely about the depth of analysis applied at the moment of encoding. Whenever a question contrasts a surface feature encoding task with a meaning-based task, and the meaning group recalls more, that is the classic levels of processing pattern. Deeper analysis at encoding means stronger memory, regardless of how much time was spent studying. Question 36. 2 groups of students prepare for a vocabulary quiz. One group rereads the list 4 times. The other group reads it once and then takes 3 short practice quizzes with corrective feedback. On a final test a week later, the practice quiz group remembers far more. Which effect is being demonstrated? Your options are A. Levels of processing, B. The testing effect, C. The reminiscence bump, D. Articulatory suppression. What's your answer? Commit to one before I continue. The correct answer is B. The testing effect. B is correct because the testing effect, also called the retrieval practice effect, captures the finding that retrieval attempts during study produce stronger, long-term retention than additional rereading. A is wrong because levels of processing emphasizes depth of encoding rather than the specific benefit of retrieval practice over rereading. C is wrong because the reminiscence bump describes the disproportionate recall of memories from adolescence and early adulthood, not the impact of practice quizzes on study material. D is wrong because articulatory suppression is a working memory manipulation that blocks rehearsal and is unrelated to long-term retention from retrieval practice. The testing effect is the finding that actively retrieving information from memory produces stronger long-term retention than spending the same amount of time rereading. It runs directly counter to most students' intuitions about how to study effectively. Each retrieval attempt is itself a learning event. Bringing information to mind strengthens the connection between cue and content, expands the network of routes to that memory, and actually restructures the trace, making it more flexible and durable than simple rereading ever could. Imagine 2 groups with equal study time. One rereads the material 4 times, the other reads once and takes 3 short practice tests with feedback. A week later, the retrieval practice group outperforms the rereading group by 20 to 30 percentage points. That gap is the testing effect. Retrieval practice doesn't have to look like a formal exam. Flashcards, writing down everything you remember, short answer questions, and spaced repetition apps all trigger the same mechanism, as long as you are actively pulling the information from memory rather than passively re-exposing yourself to it. When study time is equal, retrieval practice consistently outperforms rereading on delayed tests. So D across ages, subjects, and material types. This is the testing effect, not a study tip, but one of the most robust findings in cognitive psychology. Question 37. Scuba divers learn a list of words either underwater or on the beach. When tested for recall, the divers recall more words in the same environment in which they learned them than in the other environment. Which principle does this illustrate? Your options are A. Levels of processing theory, B. The phonological similarity effect, C. Articulatory suppression, D. Encoding specificity including state-dependent effects. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. Encoding specificity including state-dependent effects. D is correct because encoding specificity holds that retrieval is most successful when the conditions at recall match the conditions at encoding, including external context and internal state. Exactly the diverse pattern. I was wrong because levels of processing predicts that deeper semantic encoding helps memory, but it does not specifically predict context match effects. B is wrong because the phonological similarity effect operates within short-term memory and does not concern environmental context at retrieval. C is wrong because articulatory suppression blocks rehearsal in working memory and is unrelated to environmental matching. Encoding specificity is one of the most powerful principles in memory research, formulated by Endel Tulving in the early 1970s. It explains why the context surrounding learning shapes how well we can later retrieve that information. The match between encoding and retrieval context can be external, like a physical location, or internal, like an emotional state. State-dependent learning is a specific version where your physiological state at study must match your state at test. Godin and Baddeley demonstrated this beautifully. Divers who learned words underwater and were tested underwater recalled far more than those tested on the beach, and the same pattern held in reverse. The environment itself became a retrieval cue. Memory is stored together with its surrounding context, the place, mood, and cognitive state present during learning. At retrieval, available cues activate stored traces. The more cues that match, the more strongly the memory is reactivated. When an exam stem describes recall improving because study and test conditions align, whether a place, a mood, or a drug state, encoding specificity is your answer. Don't confuse it with levels of processing, which is about encoding depth, not context match. Question 38. A 70-year-old woman is asked to list her most vivid life memories. She produces a disproportionate number from her teens and 20s, fewer from middle age, and a smaller cluster from recent years. Which phenomenon does this pattern illustrate? Your options are A. The reminiscence bump, B. Source monitoring error, C. The misinformation effect, D. Proactive interference. Which would you go with? Lock it in before the reveal. The correct answer is A. The reminiscence bump. A is correct because the reminiscence bump captures the finding that older adults disproportionately recall vivid memories from adolescence and early adulthood, the pattern described in the scenario. B is wrong because A source monitoring error would mean misattributing the origin of a memory, not the lifespan distribution of memories themselves. C is wrong because the misinformation effect involves post-event distortion of an existing memory, which the question does not describe. D is wrong because proactive interference occurs when older information disrupts learning of new information, a different phenomenon from the lifespan recall distribution. The reminiscence bump is one of the most robust patterns in autobiographical memory research. It explains why older adults don't recall their lives evenly. Instead, a specific window of time dominates their most vivid memories. Recall across the lifespan follows a predictable shape. Infantile amnesia blocks memories from before age 3 or 4. Recent events get a small boost from recency, but the dominant peak, the bump, sits squarely in adolescence and early adulthood, roughly ages 10 through 30. 3 major hypotheses explain the bump. The cognitive hypothesis points to the flood of novel experiences in young adulthood. The self-image hypothesis ties it to identity development during adolescence. The cultural life script hypothesis credits milestone events, first jobs, marriages, that create a shared narrative scaffold. These explanations are complementary, not competing. The exam danger is conflating the bump with other memory phenomena. Flashbulb memories are vivid snapshots of single events, not a lifespan pattern. The misinformation effect distorts an existing memory. proactive interference is about old learning blocking new learning. The reminiscence bump is specifically the overrepresentation of memories from ages 10 through 30 in older adults. When you see autobiographical memory, lifespan distribution, or ages 10 through 30 in an exam question, think reminiscence bump. Documented by David Rubin, it is the most replicated pattern in the study of how personal memory is distributed across a lifetime. Question 39. People who lived through the September 11th attacks often report extremely vivid memories of where they were, what they were doing, and how they heard the news. Even years later, the vividness can persist even when objective accuracy decays. Which type of memory is this? Your options are A. Procedural memory, B. Iconic memory, C. Flashbulb memory, D. Working memory. Don't overthink it. Which one feels right? The correct answer is C. Flashbulb memory. C is correct because flashbulb memories are vivid, detailed memories for the circumstances of learning about a significant emotional event, marked by high subjective confidence even when the underlying accuracy slips. A is wrong because procedural memory stores motor and cognitive skills, not autobiographical scenes tied to a public event. B is wrong because iconic memory is a brief visual sensory store lasting under a second, not multi-year vivid recall. D is wrong because working memory holds information temporarily during a task, not the years-long vivid event memories described. Flashbulb memories are vivid, long-lasting autobiographical memories, but not for the event itself. They capture the surrounding circumstances of learning about a significant, emotionally charged event, where you were, who you were with, and how you heard the news. Brown and Kulick coined the term in 1977, studying how people remembered learning of JFK's assassination. The memory locks onto the reception context, the surrounding details, rather than the historical event directly. Research reveals a striking dissociation. Confidence in flashbulb memory stays high, while actual accuracy fades at roughly the same rate as ordinary memories. The memory feels sharp, but details shift silently across years of retelling. Two forces make these memories feel exceptional. Strong emotional arousal drives intense initial encoding, and cultural significance prompts repeated retelling, which keeps the memory vivid, but also introduces distortions with each recall episode. The key distinction on any exam: flashbulb memory is a long-lasting autobiographical memory for the circumstances of learning about an emotionally significant event. Vivid and confidently held, but not uniquely accurate. Don't confuse it with iconic, procedural, or working memory. Question 40. Witnesses to a staged car crash later read a news story that incorrectly mentions a stop sign at the scene. When questioned days later, many witnesses confidently report seeing a stop sign, even though there was a yield sign. Which phenomenon does this illustrate? Your options are A. Proactive interference, B. The misinformation effect, C. The serial position curve, D. The reminiscence bump. Got a guess? Lock it in. The correct answer is B. The misinformation effect. B is correct because the misinformation effect occurs when post-event information distorts a witness's memory of the original event, a finding tied to Loftus's classic work and to the constructive nature of memory. A is wrong because proactive interference involves older memories disrupting new learning, not later information warping memory of a past event. C is wrong because the serial position curve describes recall as a function of list position, unrelated to memory distortion through misinformation. D is wrong because the reminiscence bump is a lifespan distribution of autobiographical memories, not a distortion produced by misleading information. The misinformation effect is one of the most important discoveries in memory research. It shows that what happens after an event can change how we remember the event itself. In Elizabeth Loftus's classic studies, participants who heard the word smashed instead of hit not only estimated higher speeds, they also falsely remembered seeing broken glass that was never in the film. A single word changed what people believed they had witnessed. 3 mechanisms drive the effect. First, witnesses fail to track where each piece of information came from. Second, each act of recall can alter the underlying memory trace. Third, memory itself is reconstructive. We build a version of the past rather than replaying a recording. The misinformation effect is specifically about post-event misleading information distorting memory for an existing event. Proactive interference runs in the opposite direction. Old memories disrupting new ones. The serial position curve and reminiscence bump describe entirely different memory phenomena. When an exam stem describes witnesses confidently reporting details that match misleading post-event information rather than reality, that pattern points to the misinformation effect. Memory is not a recording, it is a reconstruction vulnerable to contamination at every stage. Question for Duen. A participant in the candle problem is given a candle, a box of tacks, and matches and is asked to fix the candle to a wall so that wax does not drip on the table. Many participants fail because they treat the box only as a container and do not consider using it as a shelf for the candle. Which barrier to problem solving is at work? Your options are A. Functional fixedness, B. Confirmation bias, C. Availability heuristic, D. The garden path effect. Which one is it? Pause the video if you need more time. The correct answer is A. Functional fixedness. That is correct because functional fixedness is the difficulty of seeing alternative uses for a familiar object beyond its typical function. The exact barrier that prevents participants from repurposing the box as a shelf in Dunker's candle problem. B is wrong because confirmation bias is a tendency to seek information that confirms existing beliefs, a reasoning bias rather than a use-based problem-solving block. C is wrong because the availability heuristic involves judging frequency by how easily examples come to mind, unrelated to repurposing objects in a problem. D is wrong because the garden path effect concerns sentence passing reanalysis, an entirely different domain. Functional fixedness is a cognitive bias that limits how we perceive objects, trapping us in their conventional uses. Understanding why this happens reveals a lot about how problem-solving can stall. Dunker, working in the 1930s and 40s, identified functional fixedness as one of the most common obstacles to restructuring. The mental shift where a problem suddenly reorganizes itself and a new solution becomes visible. In the candle problem, participants are given a candle, a box of tacks, and matches, and asked to mount the candle on a wall without dripping wax. Most people never consider emptying the tack box and using it as a small wall-mounted shelf, because their brain has already categorized the box as a container. The bias can be loosened. Presenting the tack box already empty, describing objects using non-standard properties, or training people in creative reuse all help break the automatic mapping from object to its standard function. When an exam stem describes someone failing to repurpose a familiar object beyond its standard use, that's functional fixedness, not confirmation bias, not the availability heuristic. The name to remember is Dunker, and the task is always the candle problem. Question 42. A puzzle solver stares at a problem for several minutes with no progress. Suddenly, the solution appears in mind in a single moment, accompanied by a strong feeling of certainty. Which characterization of problem solving best fits this experience? Your options are A. Means-ends analysis through stepwise subgoals, B. Trial and error using brute force. C. Insight. D. Algorithmic search through every possible state. Take a second. Which answer would you pick? The correct answer is C. Insight. C is correct because insight, emphasized by the Gestalt psychologist, refers to the sudden, often surprising arrival of a solution after a period of unproductive effort, accompanied by a feeling of certainty. A is wrong because means-ends analysis involves deliberate, stepwise reduction of the gap between current and goal states, not a sudden flash of solution. B is wrong because trial and error proceeds through gradual, observable attempts rather than a single instantaneous solution. D is wrong because algorithmic search systematically considers every possible state, a deliberate process that does not match the abrupt feeling described. Insight is a distinct mode of problem solving, one where the solution arrives suddenly, all at once, after a period of impasse. It's not the same as gradually working toward a goal, and understanding why makes it one of the most fascinating topics in cognitive psychology. Every insight episode has 3 recognizable features. First, a period of genuine impasse where normal effort fails. Then incubation, often unconscious processing while attention is elsewhere. Finally, the aha moment, the solution snaps into place with a strong feeling of certainty. Analytical problem solving reduces the gap between the current state and the goal step by step. Warmth ratings rise steadily. Insight problems stay cold throughout the impasse, then jump to solution all at once. Köhler's chimpanzees showed exactly this pattern: inactivity, then sudden purposeful action. The block in insight problems is usually a hidden assumption baked into your initial mental representation. Conscious effort tends to reinforce that bad framing rather than escape it. Incubation lets the unhelpful assumption fade, allowing an entirely new representation, and with it, the solution to surface. Brain imaging confirms the difference. Insight solutions produce a distinct burst in the right anterior temporal cortex, absent in analytical solutions. When an exam stem describes stalled effort followed by a sudden, certain solution, that's the Gestalt insight pattern, not trial and error, not means-ends analysis. Question 43. A participant who has just solved a story about a general dividing his army to attack a fortress from multiple directions later faces an unrelated medical problem about destroying a tumor without harming surrounding tissue. He notices the structural parallel and applies the divide and converge solution. Which mechanism is supporting his solution? Your options are A. Functional fixedness, B. Analogical transfer, C. Confirmation bias, D. Working memory chunking. Before I reveal it, which one do you think is right? The correct answer is B. Analogical transfer. B is correct because analogical transfer is the use of a solution structure from one domain to solve a problem in another, exactly the move from the military story to the radiation problem in Gick and Holyoake's classic studies. A is wrong because functional fixedness blocks new uses for objects rather than supporting transfer between problems. C is wrong because confirmation bias filters evidence in favor of an existing belief, not a transfer mechanism between problem domains. D is wrong because chunking groups items into meaningful units in working memory and does not explain cross-domain solution transfer. Analogical transfer is the process of taking a solution structure from one problem and applying it to a completely different problem that shares the same underlying form. The two problems may look nothing alike on the surface, yet their abstract structure is identical. In Gick and Holyoake's classic studies, participants who read about a general dividing his army to converge on a fortress were far more likely to solve a separate medical problem requiring rays to converge on a tumor. The military and medical scenarios share the same divide and converge structure, even though their surface features are completely different. Transfer requires 3 steps: retrieving the source problem, establishing a structural mapping between source and target, and adapting the mapped solution to the target specifics. Failure at any single step can block transfer entirely. Retrieval is especially sensitive to surface similarity, while mapping is harder for novices than experts. Be careful not to confuse analogical transfer with related concepts. Functional fixedness blocks new uses for objects. Confirmation bias filters evidence toward existing beliefs. Chunking groups items into meaningful units. Analogical transfer specifically means applying a solution structure from one problem to another with the same abstract form. Whenever an exam stem describes someone applying the structure of one story or problem to solve a superficially different problem, that is analogical transfer, look for signal phrases like source and target problems, structural similarity, and the names Geck and Holyoke. Question 4 here. A radiologist quickly identifies a small abnormality on a chest scan that a novice misses, because she expects the kind of pattern that fits the patient's history and her years of training. Her processing is heavily guided by stored knowledge and expectations. Which type of processing is most prominent here? Your options are A. Sensory-only processing, B. Bottom-up processing alone, C. Iconic memory readout, D. Top-down processing. What's your answer? Commit to one before I continue. The correct answer is D. Top-down processing. D is correct because top-down processing uses prior knowledge, expectations, and goals to shape perception, and the radiologist's expert recognition of subtle patterns guided by experience is a textbook case. A is wrong because pure sensory processing without high-level guidance would not capture the role of stored knowledge described. B is wrong because bottom-up processing alone is data-driven and does not include the expectation-driven guidance the scenario emphasizes. C is wrong because iconic memory readout refers to brief visual sensory storage, not knowledge-guided pattern recognition. Perception isn't just about passively receiving sensory signals. It involves 2 directions of processing that constantly interact: bottom-up, driven by raw sensory data, and top-down, shaped by prior knowledge and expectations. Bottom-up processing builds perception from raw sensory input alone. Top-down processing uses stored knowledge and expectations to guide interpretation. In real perception, both directions operate simultaneously, with each influencing the other. Cortical feedback connections allow higher-level brain regions to send predictions down to lower sensory areas. When predictions match incoming signals, recognition is fast. When they mismatch, the discrepancy triggers further processing and updates the prediction. A radiologist with 20 years of experience spots a subtle lung abnormality that a novice completely misses. The sensory input is identical. What differs is the top-down knowledge priming relevant features in advance. Top-down processing doesn't replace bottom-up, it refines it. When a STEM describes expert recognition guided by prior experience, that's the hallmark of top-down processing at work. Question 45. A graphic designer draws 2 curving lines that briefly cross at a single point. Most viewers see 2 continuous curves passing through each other, rather than 4 separate line segments. Which Gestalt principle best explains this perception? Your options are A. Good continuation, B. Closure, C. Proximity, D. Common region. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is A. Good continuation. A is correct because good continuation predicts that viewers perceive lines as following the smoothest, most continuous path, leading them to see two curves crossing rather than four separate segments. B is wrong because closure refers to the tendency to fill in missing portions of a contour to perceive a complete shape, a related but distinct principle. C is wrong because proximity groups elements that are physically close together, which does not directly explain the perception of continuous curves through a crossing point. D is wrong because common region groups elements within a shared bounded area and is not the principle behind continuous curve perception. Good continuation is the Gestalt principle that explains why elements along a smooth, continuous path are perceived as belonging together. It's one of several organizing rules the visual system uses to make sense of a noisy retinal image. Max Wertheimer identified these principles as defaults the visual system uses to favor the most likely interpretation of a scene. Good continuation specifically favors low curvature, predictable paths over abrupt changes. When two curves cross at a single point, good continuation causes us to perceive two smooth curves passing through each other, rather than four separate segments meeting at a corner. The preference is automatic and operates below conscious awareness. The exam trap is confusing these four principles. Closure fills in missing contour gaps. Proximity groups elements that are physically close. Common region groups items sharing a bounded area. Good continuation is specifically triggered by smooth paths at crossings or junctions. Whenever a question describes two curves crossing and being perceived as continuous rather than as four separate segments, good continuation is the operative principle. Smoothness at the junction is the key diagnostic feature. Question 46. A 1958 model proposes that attention works as a hard filter early in processing, allowing only one selected message through based on physical features such as voice, pitch, or location, while completely blocking unattended messages. Which model does this describe? Your options are A. Treisman's attenuation model, B. Levy's load theory, C. Broadbent's early selection filter model, D. Schneider and Schifrin's automatic processing account. Which would you go with? Lock it in before the reveal. The correct answer is C. Broadbent's early selection filter model. C is correct because Broadbent's 1958 filter model proposed an early, all or none selection based on physical features, a foundational early selection account in attention research. Is wrong because Treisman's attenuation model softens Broadbent's filter by allowing unattended messages to be weakened rather than fully blocked. B is wrong because Levy's load theory is a later perceptual load account of when irrelevant information is processed, not the original hard filter model. D is wrong because Schneider and Schifrin distinguished automatic from controlled processing and did not propose the early filter described. Broadbent's filter model, published in 1958, was the first major structural account of how attention selects some information and ignores the rest. It belongs to the early selection tradition in cognitive psychology. Broadbent proposed a single bottleneck through which only one channel can pass at a time. The filter selects based on simple physical features, such as which ear a message arrives in, and the unattended message is blocked entirely before any semantic analysis occurs. Selection at the filter is driven by low-level physical properties of the signal, not its meaning. Broadbent's model deliberately treats the listener as an information channel with limited capacity at the specific structural point. Treisman's attenuation model softened Broadbent's hard filter after evidence showed some unattended content, like hearing your own name, breaks through. Levy and Schneider and Schifrin address different questions entirely. Broadbent's unique contribution is the original hard early selection filter. When an exam stem describes a single bottleneck that selects by physical features and blocks unattended messages entirely, that points specifically to Broadbent's 1958 filter model, the foundation of the information processing tradition in cognitive psychology. Question 47. A participant in a dichotic listening task is asked to shadow one message in the right ear while ignoring another in the left. Yet, when her own name is spoken in the unattended ear, she notices it. Which model best accounts for this finding? Your options are A. Broadbent's early selection filter model, B. Treisman's attenuation model, C. Schneider and Schifrin's automatic processing account, D. Larvey's load theory in a high load condition. Don't overthink it. Which one feels right? The correct answer is B. Treisman's attenuation model. B is correct because Treisman's attenuation model holds that unattended information is weakened but not fully blocked, and highly meaningful items like one's own name can still pass through when their threshold is low enough. A is wrong because Broadbent's strict early filter would block unattended messages completely and cannot easily explain noticing a personal name in the unattended channel. C is wrong because Schneider and Schifrin's account distinguishes automatic from controlled processes generally, but the attenuation model is the specific framework for selective listening. D is wrong because Levy's load theory predicts more processing of irrelevant material under low rather than high load, not specifically that personal names slip past attention. Treisman's attenuation model builds on Broadbent's work by replacing the idea of a hard filter with something far more flexible. Rather than blocking unattended information entirely, the model proposes that it is weakened, attenuated, but still allowed to pass through. Unattended input travels through the filter at reduced strength and reaches what Treisman called dictionary units, long-term memory representations of known items. Each unit has a recognition threshold. Highly meaningful items, like your own name, have very low thresholds and can activate even from a weakened signal. The key structural difference is that Broadbent's model stops unattended messages cold, while Treisman's model lets them through at reduced power. Only items whose dictionary thresholds are low enough, because they are personally meaningful or contextually relevant, will actually reach conscious awareness. Think of the attenuated channel as a crowd of weakened signals outside a club. Most never get in, but a few, your name, an urgent word, are on the VIP list and pass the threshold immediately, pulling your attention away from whatever you were focused on. When an exam stem describes unattended information slipping through because of personal meaning or a low recognition threshold, that is Treisman's attenuation model, not Broadbent's hard filter, not load theory, not automatic processing. Question 48. A participant is asked to name the ink color of word shown on a screen. When the word red is printed in blue ink, response time slows compared with an unrelated word printed in blue ink. Which classic effect does this slowing illustrate? Your options are A. Functional fixedness, B. The phonological similarity effect, C. The garden path effect, D. The Stroop effect. Got a guess? Lock it in. The correct answer is D. The Stroop effect. D is correct because the Stroop effect demonstrates that the automatic process of reading interferes with the controlled process of naming ink color when the printed word and the ink color conflict. A is wrong because functional fixedness is a problem-solving block tied to object use, not interference between automatic reading and color naming. B is wrong because the phonological similarity effect concerns memory confusions among similar sounding words, not response time interference between word meaning and ink color. C is wrong because the garden path effect refers to syntactic reanalysis when an initial pass fails, unrelated to color word interference. The Stroop effect captures something fundamental about how our minds handle competing information. Understanding it means understanding the tension between automatic and controlled mental processes. Reading is so deeply practiced in literate adults that it runs automatically. You can't easily stop it. Color naming, by contrast, requires deliberate, controlled attention. When a word spells one color but is printed in another, these two pathways collide, and the automatic reading process hijacks cognitive resources meant for color naming. In a neutral trial, a non-color word like table printed in blue causes no conflict. Participants respond quickly, but when the word blue appears in red ink, the automatic reading of blue competes directly with the correct answer, red, producing measurable slowdowns, often hundreds of milliseconds long. Resolving the conflict isn't free. It recruits brain regions like the anterior cingulate cortex and dorsolateral prefrontal cortex. The mental effort needed to suppress automatic word reading and select the correct color response is exactly what makes the Stroop task such a powerful tool for measuring executive control. Whenever an exam describes someone slowing down while naming ink color because the printed word names a different color, that's the Stroop effect, a direct window into how automatic processes can override deliberate ones. Question 49. A person convinced that a particular weather app is more accurate than a competitor pays close attention every time it forecasts correctly and quickly forgets the days it gets the forecast wrong. Which reasoning bias is most prominent? Your options are A. Confirmation bias, B. The conjunction fallacy, C. Base rate neglect, D. Risk aversion under uncertainty. Which one is it? Pause the video if you need more time. The correct answer is A. Confirmation bias. A is correct because confirmation bias is the tendency to attend to, remember, and overweight information that supports an existing belief while disconfirming evidence. Exactly the user's behavior toward the weather app. B is wrong because the conjunction fallacy occurs when people judge the probability of two events combined as higher than one of them alone, a different reasoning error. C is wrong because base rate neglect is the failure to use prior probabilities when judging an event, not specifically the selective attention to confirming evidence described. D is wrong because risk aversion describes a preference for certainty over equal expected value gambles, unrelated to selective attention to confirming forecasts. Confirmation bias is our tendency to seek out, remember, and overweight evidence that supports what we already believe, while discounting anything that challenges it. It operates below conscious awareness, shaping belief formation even in people who consider themselves open-minded. The bias works at multiple levels simultaneously. We preferentially notice confirming evidence, recall it more vividly, apply harsher scrutiny to disconfirming evidence, and seek out sources that already agree with us. The result is a self-reinforcing loop that strengthens beliefs regardless of their accuracy. At the level of attention, we notice confirming facts. At the level of memory, we retrieve them more easily. And at the level of evaluation, we hold disconfirming evidence to a much higher standard, raising the bar precisely when it would force us to update. On exams, the key signal for confirmation bias is selective attention to successes of a favored option while overlooking its failures. If a STEM describes someone filtering evidence to protect an existing belief, that's confirmation bias, not the conjunction fallacy, base rate neglect, or availability. Karl Popper argued that genuine knowledge advances by falsifying hypotheses, not confirming them. Safeguards like double-blind trials and peer review exist precisely because unaided human reasoning tends to do the opposite, and awareness of the bias alone is rarely enough to overcome it. Question 50. Two surgeons describe the same procedure to comparable patients. One says the surgery has a 90% survival rate. The other says it has a 10% mortality rate. Patients hearing the survival framing are more likely to consent. Which decision-making phenomenon does this illustrate? Your options are A. The availability heuristic, B. Base rate neglect, C. The framing effect, D. The conjunction fallacy. Take a second. Which answer would you pick? The correct answer is C. The framing effect. C is correct because the framing effect captures the finding that logically equivalent descriptions of an outcome can produce different choices when one frame highlights gains and another highlights losses. Exactly the surgeon contrast. A is wrong because the availability heuristic involves judging likelihood by ease of recall, not the same information different frame effect described. B is wrong because base rate neglect is the failure to incorporate prior probabilities, a different reasoning error. D is wrong because the conjunction fallacy applies when people overestimate the probability of joint events, not the gain versus loss framing manipulation described. The framing effect is the finding that logically equivalent descriptions of the same outcome can produce different choices, simply by emphasizing gains versus losses. This pattern, introduced by Kahneman and Tversky through prospect theory, shows that how an option is worded matters just as much as what the option actually is. The classic Asian disease problem illustrates this perfectly. Told that a policy would save 200 lives, people preferred the certain option. Told that 400 would die, people gambled on the risky option, even though both descriptions refer to exactly the same outcome. The mechanism lies in prospect theory's value function. People evaluate outcomes as changes from a reference point, not in absolute terms. Losses feel roughly twice as painful as equivalent gains, so framing an outcome as a loss versus a gain shifts which side of that reference point it lands on, changing how attractive it feels. A common exam mistake is confusing framing with other biases. The framing effect is specifically triggered when two logically identical options produce different choices because of gain versus loss language, not because of memory, prior probabilities, or event conjunction. Whenever a question describes the same probability or outcome producing different decisions based purely on wording, that is the framing effect. Risk aversion in gain frames, risk seeking in loss frames. Kahneman and Tversky's enduring insight into how the mind is swayed by description.
You have reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.